All right, let's try this flux integral. I know, isn't it scarring? All right, so flux integral, not scarring. So I want to. Okay. Fair point. All right, I'm sorry, I've scarred you with flux integrals. Let's try this one. Maybe we can work each other through it. Get a friend, hold hands if you need to. All right, so let's calculate the flux through the surface of the vector field F, where F is y times j. And S is the part of a radius 2 cylinder with x is bigger than 0, y is bigger than 0, and z is between 0 and 3, oriented towards the z-axis. Okay, cool. All right, so first things first, picture? Or remember the dV or d area thing? Both?
Same time.
Okay, same time. Super inconvenient. All right, what was the area again? Okay, cosine theta, sine theta, and 0 times. Okay, what's r? Yeah, perfect. The radius is 2 in this case. And then there's times dz d theta. And we don't have to adjust this one, right? Because this is a radius 2 cylinder that seems to be around the z-axis, right? I guess they didn't tell me that, but they probably should have. I should have told you that. And then what do these bits mean? X is bigger than 0, y is bigger than 0. That means it lives in what? What the heck was I drawing here? It was drawing a quarter cylinder, right?
What?
Why was it drawing a quarter cylinder?
Because it's only the values on the XY frame.
So it's that back half. X, Y, but our front half.
Yeah, so this should be the back half, right? So X goes this way, Y goes this way, and this is the level, Z is 3, right? At the bottom here, I've got the level, X goes this way, Y goes this way, and this is the origin. You guys with me on this? Playing along, Alex, or did I spook you out here?
No, I'm good.
Okay, so now what?
It says it's oriented towards the z-axis, so wouldn't it be
0, y.
opposite?
Oh, good. So this thing's oriented outwards, right? These point away from 0. If I'm going to go oriented towards the z-axis, right, I really should kind of, this vector, right, sticks out of this thing.
So which way are we going through is the question.
Yep, so I should be talking about going in that way. You guys see that? So I need to flip this thing over. So I need, how do I flip it over?
Negative sign.
Yeah, throw a negative sign, where?
All the way out.
Yeah, any place, here, here, or on both of those, whatever. I'm gonna put it here because it'll be more convenient. Put it someplace. All right, so if I'm gonna get the integral over the surface F of the vector field, or sorry, integral over the surface S of F, pretty sure I can make that a double integral, right? And then what are my du whatever is gonna be here?
dz theta?
dz and d theta. Okay, and then, oops, we're gonna need more space than that. dz and d theta. Okay, what's my d area thing? I guess I've got all of that, right? There's a -2 and a vector cosine theta, sine theta, 0.
So now we need to put our field in terms of
Perfect. I'm going to put my field in terms of
our shape.
what I'm talking about, right? Z's and thetas. So what's y in terms of z's and thetas? R sine theta, R being 2. So this is 2 sine theta j dotted with that stuff.
And you can pull out all the constants.
Yep, and then we can jam on some constants. Where to, where from here?
0 to 3 and 0 to 5 or 2.
0 to 3 for the z's makes sense, and 0 to, what did you say?
Pi over 2.
Why did you think pi over 2?
Because it's a quarter, it's the first quadrant on that side.
Perfect. First quadrant goes from 0 to pi over
And it
2.
wouldn't really matter assuming you chose that size, right?
What do you mean?
Like if you went pi over 2 to pi.
Oh,
I know you were supposed to stay in that plane, I'm just saying in general.
So it might matter, yeah. Yeah, especially if I did something silly like the other half.
Yeah.
That would really make a difference. Yeah, so I think those need to be. Alright, what do I get when I dot product here? Seems like I've got a -4 constant, right? And then integral from 0 to pi over 2, integral from 0 to 3 of what? Sine squared theta dz d theta. You okay?
It almost died.
Slipped. It's fine. Got excited.
Okay. All right, now what? So equals, what do you do?
Slap a Z on there. Integrate.
Slap a z on there and integrate? Okay. So the dz part, right, doesn't care about any of this stuff. So what am I going to get out of the dz part?
3 sine.
Seems like I'm going to get 3 sine squared. So I got -12, the integral from 0 to pi over 2. Sine squared theta d theta.
Right?
Okay, half angle m, yeah. So I get -12, what?
1 minus cosine 2 theta over 2.
1 minus cosine 2 theta over 2. What did I screw up?
But that's integrated. That's already integrated.
Yeah, that stuff needs to be integrated from 0 to
I
pi
mean,
over 2.
that 1 minus. Oh, no, sorry. Yeah.
How one?
Take out the 2 -6.
Okay, so cancel a little bit. Okay, so I got -6, the integral from 0 to pi over 2 of 1 d theta minus the integral from 0 to pi over 2 of cosine of 2 theta d theta. Oops. Closing parenthesis. All right, what do you know?
Cosine of 2 pi goes to 0.
Cosine of 2 pi's piece go to 0. Why?
Because it's pi over 2 times 2, so it's cosine of pi.
Yeah.
Perfect. Or it's the integral of cosine from 0 to pi, right? So that's half on top, half on bottom. Cancel, cancel. Good deal. All right, so I get what?
I have
Negative
3
3 pi.
Or sorry.
-3 pi.
Yeah.
Cool. Good deal. What's that tell you?
Stuff's about to flow back out.
Yeah, stuff tends to flow out of this thing apparently. Okay, so that the flux is negative, so it's going the other way.
But because we put a negative, it's
Yeah, so if they had asked us oriented outwards, right, then I would have gotten
3 pi.
positive 3 pi.
What's that?
right? Because if I flip my perspective and I'm no longer talking about how much stuff goes through that way, I talk about how much stuff goes through this way, but it's going to be the same thing, but with a minus sign.
Okay. And so that minus 3 pi, we measured it going inwards, and that minus 3 pi means it's actually going outwards?
Yep.
Okay.
Perfect.
Did you get the 2? I don't remember how you got the 2. I know how you got the sign.
This too?
Yeah.
That's from y is r sine theta.
Oh, okay.
And in this case, r, right, the radius of the cylinder is stuck in 2. Cool. This thing is a little bit less versatile, by the way, than like cylindrical coordinates. If you try to do this technique with a cone, it doesn't work. Right, this D area thing we created, it's good for cylinders and only cylinders.
R is constant.
Because I set R as constant, yeah. So there's no function, there's no changeability there. You guys cool with that?